6.11. Question number 2. State that the state of a gas can be described by quoting the relationship between. The correct option is repeated twice. We all know that PV equal to nRT relates all the variables of the gas. So here we can see that it is a relation between pressure, volume and temperature. So this would follow option A and option D, which is basically the same. Question number 3. In an adiabatic process, no transfer of heat takes place. In an adiabatic process, no transfer of heat takes place. So Q would be equal to 0. Then we have to choose some options. In options A, C and D, they follow with Q equal to 0. So the first part is correct. Now the option A states delta T is not equal to 0. That means delta U is not equal to 0. Delta U is equal to Q plus W, as we all know the first law of thermodynamics. W is equal to 0. But that is not possible. If Q is equal to 0, this is not equal to 0, then this should be not equal to 0 for the equality sign to hold. So this is wrong. We can't go with it. If Q equal to 0, the option C, and if delta T is equal to 0, that means delta U is equal to 0. So W is ought to be 0. So this is our confined answer. Question number 4. Work done is equal to P external into dV. V1, V2. If the process is reversible process, P external is substituted by P internal, and we can say P internal is variable. It is a property of gas until in a isobaric process. So since P external is constant, work done in irreversible is always greater than work done is reversible. Work done in reversible process. Moving forward to question number 7. Question number 7. The enthalpy of sublimation. Sublimation involves solid to gas. Since enthalpy is additive for two reactions, if I convert solid to liquid and then I convert liquid to gas, delta H1 will be equal to delta H2 plus delta H3. So enthalpy of sublimation is equal to enthalpy of fusion plus enthalpy of vaporization. So option A would follow. Question number 9. For an exothermic reaction, that means heat is given out. So Q will be negative. Heat is given out. Okay, heat is given by the gas. If heat is given out, then of course the internal energy change, the enthalpy change of the container will be negative. The final energy will be less than the initial energy, so enthalpy change will be negative. Question number 15. I define the electronic configuration of most electronegative element. Now see, since the for the most electropositive element, since the element need to be most electropositive, it should contain only one valence electron, and the size should be as large as possible. I mean the given option C contains element with one valence electron and having 6 periods, having 6 orbits. So option C would be our answer.